Okay, so on to question number 3. A 500 ml buffer solution is 0.1 molar in HNO2 and 0.15 molar in potassium nitrate. Determine if each addition would exceed the capacity of the buffer to neutralize it, and then they give different milligrams, different masses of these certain compounds. So we want to determine if the pH will change greatly if this amount of either acid or base is added to the buffer. Okay, so let me just write down everything that we know. So we know the volume of the buffer is 500 mils. I'm going to convert that to 0.5 liters. And then I'll write down the concentration HNO2 is 0.1 moles per liter. Concentration KNO2 is equal to 0.15 molar. And then from here, it's also good practice to just calculate the number of moles since you're given volume and concentration. So I'm just going to do that right now. So the number of moles is equal to concentration times volume. So for the first one, let's do HNO2 first. And then its concentration is 0.1 moles per liter. And then I'm going to multiply by 0.5 liters. And then you get a value that is equal to 0.05 moles. So that's for HNO2. And then I'm going to do the same thing for the KNO2. It's equal to 0.15 moles per liter times the volume. And then you end up with 0.075 moles. Okay, another important thing that we want to find out, what value is the Ka. So this is a constant that's given to you, and it depends on what the acid is. So I'm going to look it up. What the Ka value of HNO2 is at 25 degrees. Okay, so then you end up with 4.5 times 10 to the negative 4. Let me just try to separate these. Okay. So the first part of the question just kind of writes down all the values. And then next, we want to calculate the pKa. So we're just going to calculate the pKa of the solution before adding anything in. And to do that, it's negative log of the Ka value, which is negative log of 4.5 times 10 to the negative 4. And then we end up with a pKa value of 3.3. And then from here, we can also calculate the pH. And to do that, it's just the pKa, which is what we just solved for, plus the log of the concentration of base over the concentration of acid. Okay, so I'm just going to plug in all these values. Our pKa is 3.3. The concentration of the base is the 0.15. And then the concentration of the acid is the 0.1. And then we end up with an initial pH of around 3.50. Okay, so that's just setting up the question. Now we're going to see what happens if you add 250 milligrams of NaOH. Okay, so first I'm going to write down the molar mass of NaOH, which is 40 grams per mole. Then we're going to do the same thing, calculate the number of moles. So I'm going to convert the 250 milligrams to 0.25 grams, just to get it all in the same units. Okay, so number of moles is mass over molar mass. And then we end up with 0.0063 moles of NaOH. So sodium hydroxide is a base. So when you add a base, we're adding to the moles of the base. And we're going to be subtracting from the moles of the acid. So it'll make sense right now. So for the moles of the acid, we started off with the 0.05. Sorry, this should read. Okay, we start off with 0.05 moles of acid minus 0.0063 moles, which is from the base. Then we end up with a value of 0.0437 moles of acid. Then we're going to find out how many moles of base there is. So it's the 0.075. This time we're going to add 0.0063 moles. Then for the total moles of base, you get 0.0813 moles. Just going to fit the last step up here, where you find out the resultant pH. Just by using that same equation, pH equals the 3.3 plus log, and then this time we're going to plug in our mole values. So for the For the base, it's the 0.0813 moles. And for the acid, it is now 0.0437 moles. Then we end up with a pH value of around 3.59. So it didn't change much. It went from 3.5 to 3.59. I'm just gonna add like what you would do if you wanted to calculate that difference. So we're gonna do something called percent change, just to quantify how much the pH changed by. So it's going to be our final minus our initial over the init divided by the initial times 100. So after adding 250 milligrams of NaOH, the pH only changed by 2.57. So then you can say this doesn't change the capacity of the buffer. Basically, you would just do the same thing that we just did for KOH, HBr, and then HI to just find out if it changes the buffer like excessively. So let's see what the junior tutor wrote. Whether or not given addition exceeds the capacity of the buffer solution contains and in solution. So here, for all of them, I'm assuming it just doesn't exceed the capacity for all four. And then they just say it's defined as the max amount of acid or base that can be neutralized by the given buffer. If excess acid or base is added, such that all the base or acid reacts respectively, exhausting any one of the buffer components completely results in the destruction of the buffer. Okay, so number of moles calculated. They made some ice tables. Yeah, so the solution looks correct. So basically, if the number of moles that you calculate here is like greater than the ones that are like here, like let's say we calculated it to be 0.06 moles and all of the acid is completely used up, then that's how you know that the buffer capacity is exceeded. So I'm just going to say that this solution is